I'm Terry Klinker. We're going to continue our discussion of decision analysis tools. We did decision making under uncertainty. We had already established what our options were. We're trying to decide what type of condos to invest in. Our options were small, medium, and large. And the states of nature, the possible outcomes, were strong demand or weak demand. And we had our payoff table for each. In the last one, that's all the information we had. So we called that decision making under uncertainty. This one's going to be called decision making under risk. What's the difference? Uncertainty means I don't know. Did I give you any information last time about the probability that we have strong or weak? No, all I said was we could have strong, we could have weak. I didn't tell you, I gave you no market analysis, no financial analysis, nothing that says this is what we expect to happen. All you knew was these were the possible outcomes. Under risk, we have some information. For instance, if I were to tell you, put this same thing up, if I were to tell you there was a 90% chance of strong demand, how many of you would invest in large condos? The answer is almost everybody. You got a 90% chance of getting that maximum return and a very small chance of losing money. On the other hand, if I told you there was a 10% chance of strong demand, those of you that chose medium and large would probably move to small because you'd have a good chance, got a 90% chance of getting that $8 million and a 90% chance of only getting 5 or losing 9 if you went with the other two. So the more information we have, the better decision we can make. So risk. Under risk, I have a probability that my states of nature can occur. In this case, I have two states of nature. So I would have state of nature A and B. The probability of state of nature A occurring is P, just some unknown P. P could be 90%, could be 80%, 50%. Since I have two states of nature and all of my states of nature must add up to 100%, the probability of state of nature B would be minus 1P. Or one minus P. 100% minus the probability of the other state of nature. Remember, it can only be 100%. When you go back to your hometowns, spring break or Christmas break, whenever, when you go back to your hometowns, I want you to look up those high school football coaches and band directors that told you they wanted 110%, and you could tell them, Professor Klinker said they're idiots. You can't have more than 100%. That's all there is. The only place you can have more than 100% is in your checkbook, and that's considered a negative thing. So when you're looking at these things, P must be between 1 and 0. 1 minus P must be between 1 and 0. You can't have more than 100%. This is for two states of nature. If I add a third state of nature, C, now, in order to know what the probabilities are, I would have P probability of A, Q probability of B, and the probability of C would be 1 minus P minus Q. If I gave you a fourth option, D, now we'd be looking at P, Q, R, 1 minus P minus Q minus R. If you go through and add all of these up, they all add up to 100%. All right? Kind of forget that for right now because we're only looking at two states of nature. We have strong and we have weak. So in this case, I would have P probability that we have strong demand. I would have 1 minus P probability that we have weak demand. So what I want to talk about now is called expected monetary value, or EMV. Expected monetary value. Now the expected monetary value depends on what P is. The bottom line here, let's pretend that P equals 0.2. If P equals 0.2, That means I have a 20% probability of strong demand, and an 80% probability, 1 minus P, 1 minus 0.2, of weak demand. What would an investment be worth here? Well, it would be quite simply the value here times P plus the value here times 1 minus P. So it would be 7 times P plus 8 times 1 minus P. P is 20%. 7 times 0.2 plus 8 times 1 minus 0.2 is 0.8. This is 1.4 plus 6.4, which is 7.8. If the probability of strong demand is only 20%, the expected monetary value of an investment in small would be $7.8 million. Medium, 14 times 0.2 plus 5 times 0.8. 14 times 0.2 is 2.8. 5 times 0.8 is 4.0. This gives me an expected monetary value of $6.8 million. Same thing for large. Got a 20% chance of getting 2 million. I've got an 80% chance of losing 9 million. So 20% times 0.2 is 4 million, plus a loss of 7.2 million gives me a net of, I expect to lose $3.2 million if I have a 20% chance of large demand. Well, I can boil this down also into a linear equation. Take a look at what I did here. All right, my expected monetary value, the expected monetary value for an investment in small demand and small condos is going to be $7 million times the probability of strong demand plus $8 million times the probability of weak demand. Go through and do some algebra here. This becomes 7P plus 8 minus 8P. So it ends up being 8. 7P minus 8P is a minus P. This is a linear equation. It's in the form of y equals b plus mx. B being your intercept, my intercept is going to be 8. It has a slope of minus 1 times the probability. It's a line. I can now tell you, based on what P is, I can now tell you what the expected value of small investment in small condos is. Once you do the market research and tell me the probability of strong demand, I can tell you what the value of it is. I can do the same thing for medium. My expected monetary value for an investment in medium is going to be 14 times the probability of strong demand plus 5 times the probability of weak demand. Again, do some algebra. And we end up with 5 plus 9P. The expected monetary value of large is going to be 20 times the probability that we have strong demand plus a minus 9 times the probability we have weak demand. Do the algebra here, and we end up with minus 9 plus 29P. So that's what we end up with. We would end up with these equations. These equations we can then use. We can put those back in an indifference table, which we defined earlier, and find out for every value of P which decision we would make. Now, I want to talk about a special case here. What if we have something called equally likely? Equally likely means we have the same probability of each state of nature occurring. That means it's a 50-50 shot. If we have the same likelihood of each state of nature occurring, then what you end up with is the expected monetary value for each one is going to equal the average of all options, of all states of nature for each option. So, if I had the same option, if I had a 50-50 shot here, this would be the average of 7 and 8 million, which is $7.5 million. Medium, 14 to 5, that's going to be $9.5 million. Large, halfway between 20 and minus 9, that's going to be $5.5 million. So equally likely just means take the average of all the values for all of your states of nature for each option, and that's the expected value. We'll show you how to do this graphically in the next video.